Hi, this is Mr. Williamson, and in this video we're going to talk about water. Again, you probably should take good notes, Cornell style if you want credit for them, if you turn them in on the day of the test. If you have any questions during the video, make sure you write them down and remember them. Put them into the Edpuzzle questions at the end, or ask me during class. I'll be glad to answer them. Again, try to focus on the details. Get listen to what all I'm saying, but what's on the screen. And make the notes yours. Let's get started. First of all, water is inorganic, meaning that there is no carbon. Inorganic means that there's no carbon. All right, and it's polar. Okay, now polar means if you think about water, it has an oxygen atom up here and two hydrogen atoms. Now, hydrogen has one electron, and oxygen has 8 or 6 in the outermost ring. If they form a covalent bond, the hydrogen electron from the hydrogen atom is going to end up down here. This electron is going to end up down here. If you add a negative to this area, it becomes negative. Two negatives becomes negative. This area becomes positive, and this area becomes positive because the electrons have moved towards the oxygen. And therefore, like I said, this becomes negative. So you have a negative area up here near the oxygen. This whole area becomes negative, and this area becomes more positive. A polar compound. It's one of the reasons that we have hydrogen bonds in a lot of the chemicals. If you watch the bonding video, we talked about hydrogen bonds. But this, again, is negative. This area down here is positive. Water has a characteristic called its adhesion. Because of that polar bond, it tends to be attracted to other surfaces. The result of this is like, and you've seen this happen. If you look at a straw, the water tends to go up the straw from where the water level is in the cup. Why? Because it's attracted to these molecules. So if we had the straw here, and this is the straw, and we have the water is actually attracted to the sides of the straw and pulled up the sides of the straw. So it's actually pulling up the side of the straw, and it can pull with quite a lot of strength. And it can work its way up the straw until the pressure of the water pulls it down. The weight of the water will pull it down. So you've got the pressure of the straw over here, or the adhesion of the molecules to the straw or to whatever surface. It could be paint, it could be your tabletop or something, to the side of the surface, and it allows it to crawl up the straw or climb up the straw. And that's where we get this thing called capillary action. Capillary action is the rise of a liquid inside of a small tube. The smaller the tube, the farther up it goes. So if you have like a big McDonald's straw, it might only crawl up this far or climb up this far. Whereas if you have a really, really thin straw, it would climb up here. But you can see where this is supposed to be. Notice where the molecules attach to the side of the glass. They're attached to the side of the glass. Okay? But the water is pulling it down because water has weight. It's being pulled down by gravity. So when the weight of the water is equal to the ability of the glass the water to attach itself to the glass up here, it pulls itself down, and that's when it stops. So the smaller tube, if you had a really thin tube here, a much thinner tube, you would see that water climb way up here, and well, okay, I didn't draw it up way up there, but you get the idea. It would climb up farther, and if we had a really, really thin tube, we would, if we had something really, really thin, or okay, it's even probably not that thin, terrible drawing, it would climb up even higher because the thinner the tube, the farther up the liquid climbs because of adhesion. This also has to do with cohesion, which I'm about to talk about next. Which is but this adhesion thing, this adhesion is what allows water to climb up 300-foot redwood trees. The size of the cells in the redwood trunk are so small that just they allow the water to climb up, like I said, 300 plus feet in a tree. It also is why you see water clinging to things like, in this case, the picture of the spider web. Why the water clings to the spider web is it's adhesion to the spider web. So the water molecules are actually attracted to the spider web and holding onto it with that polar properties, holding on the spider web. Cohesion is the force of water attracting to each other. So you have one water molecule here. We'll just draw a whole bunch of water molecules. And the water molecules are attracted to each other. And it's what gives water its surface tension. But each water molecule is attracted to one another. So every one of these water molecules, and I'll probably miss some here, are attracted to each other. The attraction is between every one of the molecules, which pulls them tight into a sphere, actually, if you really want to know. They're attracted into a sphere-like shape. I think I got them all. And each one of those is attracted to each other. And that's why you have like surface tension. And you've probably done this. We're going to do it in class, where you can take a cup of water and you can float inside of it. You can have the water here. You can float a paper clip or something light, a piece of metal, which should sink. You can float a paper clip on top of it, and it will stay on top of the water. It's why the little water strider bugs are able to walk across the water. It's why it hurts when you fall off a diving board and do a belly flop or land on your back. The water's fairly soft, but the surface tension is so strong that your body is absorbing that surface tension, that cohesion. The attraction of the molecules is so strong that it can hurt your body when you hit the water. It can actually kill you if you fall from high enough height. But it's also why you see this attraction here, where you see this round ball. All the little drops in this are round, because if you think of a water molecule in a three-dimensional space, not only is it pulling in on the directions that I'm at, but it's also pulling in like towards you and away from you. So it's pulling in this way, it's pulling in that way. It comes in and it forms a sphere. So all the water molecules in this one sphere here or this sphere here are all pulling towards the center, and the smallest space they could take up when that happens is a sphere. And that's why water droplets form spheres. So you have adhesion, which attracts them to other things, water molecules to other things, and cohesion, which makes them form a sphere. The other thing about cohesion that occurs is it causes water to heat up very quickly, very slowly, or cool down very slowly. In other words, it has a high heat retention. Heats up or cools down. I'm trying to write neater for you guys. Think about this. If you put a pan onto the stove and you turn on the burner to high, the pan heats up really quickly. But if you put water in that pan, the water takes a long time before it starts to boil, because you have to add so much heat into the pan. This is a terrible drawing of pan. I don't want to hear about it in class, guys. Okay, you had so much heat going into the pan that the water and being absorbed by the water, it takes a lot of energy to separate and to move the water molecules enough to where you raise the temperature. And in chemistry, you probably will actually do an experiment where we measure the amount of water or amount of energy that you have to put in to a pan or into a certain amount of water to get it to actually heat up and to change the states of matter from a liquid to a solid, liquid to a gas, cause evaporation. It's also why when you turn the stove off, it cools down really slowly. You turn it off, yeah, it stops boiling right away if you have a gas range, but it stays hot. I don't encourage you to do this, but think about it. You turn the pan off, it stops boiling. You're not going to stick your finger in it right away because it maintains that heat, and that as a result It's because it cools down. It all has to do with this cohesion, the attraction between molecules. It takes energy, time for that energy levels to change, to either heat up or slow down. So that's water. We're going to talk about it more in class. We're going to take a look at its properties, the adhesion properties and cohesion, and we're going to talk about those a little bit more and have some activities that hopefully you'll take a look at, or at least we'll hopefully do that. If you have any questions, again, make sure you ask me in class, or make sure you mention them in the Edpuzzle questions at the end of the video. I wish you luck. I hope you're studying for the test. Have a good day. Good luck.